Sometimes it is needed to extract very specific color information like hue, luminance, saturation, the average RGB, the intensity of a color, the alpha channel. To be able to do this with displacement map, the shader called scalar matte is designed to do these sort of things. This shader can be found under color channels, scalar matte. Now this shader acts also as a conversion shader where it could take the actual color input and change it into a displacement map or a scalar value. Now the scalar matte has two options or two-stage processing. The first thing is component extraction. So you can actually go in either in RGBA, HLS, HSV and select the actual component you would like to extract. For example, if you wanted to extract the alpha channel of an image, this shader will allow you to do this. Now also this shader can also invert the actual displacement map automatically for you because there's an embedded invert capabilities inside the component extraction. So you don't need to add an extra shader in there to do the inversion. Now we'll simply remove the invert, and so we could get it back to the unaltered value. Now the component range is a what we call a way to extract luminance information. So let's say, for example, this is a displacement map value 0 and this is a displacement map value 1. So as you can see here, it goes from 0 to 1. So it's some sort of a grayscale ramp being put over the surface of the grid. Now if I enable this option here, as you can see here, I will extract a very specific luminance information out of this grayscale. So what I'm saying to this shader, anything that is that has luminance greater than 0.2 but lower than 0.1, I would like you to extract this and return 0.9 as the output. So this creates this this sort of luminance extraction. So I can actually make the minimum and maximum delta, which is the delta between this value. So this is 0.2, this is 0.8, and these 0.1 are basically the fall off that occurs on both sides right here. Now if I make these value very small, for example, I will have a very sharp fall off right here. So it's extracting only luminance value that range between 0.2 and 0.8. Whenever the value, the luminance value, it's considered between 0.8 and 0.2, the inside value will be returned at the output. So you see that you get a value of 0.9 right here. Now the outside value is being returned as being 0. So anything that is below 0.2 or greater than 0.8, which is the minimum and maximum, will be returned, the output will return 0. So I can actually make this value minus 0.9, for example. So now I can have a very interesting displacement map setup with this, and I can actually apply some sort of remapping to be able to do the displacement map mathematics, everything into one shader. Now for example, I could say I want to add 0.5 and 0.8. Now we'll start to have some sort of fall off on the side here, so this way it's not fully straight but has some sort of slope. This is really a great shader because the interesting aspect of this shader is that you can texture any of these parameters. So for example, if we want to have a certain texture to appear right here and certain texture to appear right here, we can actually drive with another shader inside and outside value with different shaders. So for example, let's go here and get a texture cell shader. The cell shader will connect it directly to the input value, so inside value. So as you can see here, I'm going to drive and create a some sort of a cell pattern directly within the value being extracted. So anything that is between 0.2 0.2 and 0.8 will have the cell, but anything that is outside will basically remains at 0. Now I can go back here and actually change this to say 0.5, and I'm going to limit the intensity extraction to be 0.2, 0.5. Also, if I add another shader to this and to be able to texture the outside value, let's say for example we use a Fractal Shader. I'm going to connect the shader right here to the outside value. Now as you can see here, I'm having any value, any luminance extraction that is considered to be outside of the extraction will get a Fractal Shader. Obviously what I'm going to do is actually lower the intensity of the fractal right here to be able to clearly show the actual fractal from the cell texture being extracted. This is really a neat way to create your own custom displacement map directly from a single image and use the grayscale to determine the place or the location where the other displacement map should be revealed. I invite you to watch the other session that will go into this shader in more details. Thank you. In the following scene we have a displacement map used to create tire treads. Let me explain the render tree here. So I'm going to disconnect the displacement map right here so we can go back to the actual surface and start to break down every shaders. This particular shader is designed to create some sort of perturbation at the surface. So as the tire runs and basically spins, it will create cracks because the ground will scratch the surface. So we want to add some sort of displacement map to the surface. But obviously we don't want the displacement map to occur on the side of the tire, but rather on the surface of the tire, right where the actual wheels touch the ground. So what we do here, we use a gradient to minimize the effect and only put it where needed. Obviously here we may need to adjust it to actually get the actual treads or surface scratch to appear at the right place. Now the intensity here of the fractal needs to be quite minimal because we're talking very subtle scratches. So we'll actually show that a little bit later. We'll use this and use the scalar mat. So as you can see here, I'm going to connect this to the back to the surface. And connect the actual displacement map here. Now what we have here, this shader extract the actual RGB average of the image, and under the component range it will extract the actual grayscale, pure grayscale. The only difference here is that by putting the minimum delta, minimum threshold and maximum threshold to all 1 to a value of 1, we can actually use that as a way to control the scaling. So if I make, for example, this very large, I can control the thickness or the depth of the actual tire treads. Now if I set it to 0.02, for example, that will give me a tire treads 0.2 soft image units in terms of thickness or depth. Now the outside value here is basically 0. If I put it to 0.1, it's going to push the surface outside. So it's kind of inflating the tire. We could actually texture this outside value to add some scratches to the surface. So let me actually put this value back to 0 and connect this shader to the outside value. The outside value will create cracks to the surface, and that will actually, if we actually zoom in right here, you'll see that the actual surface will create some cracks without actually destroying any of the treads. So by going to fractal, we can control the how the actual thickness is, the actual height of these scratches will be. So you can also control the frequency or density of the scratches. So if we go back here to fractal, we can adjust the actual thickness as we see fit. If I zoom back here, and we see that we have connected the scalar mat. We add a negate. The negate is important because everything but that we've been doing here was positive. So this was returning a positive displacement map, and this one was also producing a positive displacement map. What I mean by positive is any value that is what will push out, and this is pretty much the same thing for this fractal. So at this point, what we want to do is we want to sort of negate the actual result so we get the crack. Obviously, as you can see, the crack is way too intense, so we'll need to lower it to be able to get the actual tire to show up properly. So that summarized the displacement map series, and I hope you enjoyed this DVD. And if you need further information, we invite you to watch the Softimage website at www.softimage.com. Thank you.